In this video, I'm going to talk about the scales of measurement in statistics. Generally, there are 4 scales in statistics: nominal scale, ordinal scale, interval scale, and ratio scale. And I'm going to talk about these 4 scales from the perspective of frequence and interpretation of ranking, where it means if we can interpret them in ranking or in the order, and if there is absolute zero, and if we can form differences or quotients, and how to transform them. And why do we need scales? Well, there are different types of variables, such as the gender, the age, the intelligence, and the salary, or the diagnosis as the categories. And we use the scales to describe these different types of variables in number, so that we can use this number to conduct the statistical analysis. And furthermore, we need the scale to do the right operation on the different types of variables. So first, let's take a look of the nominal scale. What is nominal scale? For example, the gender, the diagnosis are the nominal scale, where we can categorize the gender as male and female. And we can also have the depressive group and the healthy group. Or we can also have the bipolar type 1, bipolar type 2, and the healthy control group. And we cannot interpret the ranking in nominal scale. It's because we cannot say male is bigger than female, or bipolar type 1 is smaller than healthy control. It doesn't make sense. And there is also no absolute zero, so that we cannot form the differences or quotients, where we cannot say male plus female or depressive group divided by healthy control. Doesn't make sense, right? And the transformation of the nominal scale is arbitrary. It means let's take a look of an example. So we have this sample, and we can categorize them in male group and female group. So we can give the number 1 to the people who are female, and we can give number 2 to the people who are male. And it could be reversed. So we can also give the number 2 to the people who are female, and give number 1 to the people who are male. And we can also give the number 10 to the people who are female, and give the number 99 to the people who are male. The code is very arbitrary. We can give any number to these 2 categories. So the next one is ordinal scale. In the ordinal scale, we can interpret the ranking and the order. So let's take a look. What is ordinal scale? The education level and the sport ranking are the ordinal scale. In ordinal scale, we can interpret the ranking or the order. So we can see primary school has lower education level than the high school, and the college has a higher education level than the high school. It makes sense, right? So, but there is no absolute zero, so that we cannot form the differences or the quotients, where we cannot see primary school plus middle school or high school times college. It doesn't make sense. the transformation is a little bit more stricter than the nominal scale. So we can take a look of an example. This is the sample. So, and we have 5 levels of the education. So we can categorize this observation or these participants into 5 groups, and we can code the 5 groups with number from 1 to 4. And we can also give them the number like this. We can give the number 5 to the primary school, the number 7 to the high school, number 7 to the middle school, and number 10 to the high school, and 15 to the college. And as you can see, the difference between the primary school and the middle school is 2, and the difference between middle school and high school is 3, and difference between high school and the college is 5. That means the difference between 2 levels in subsequence could be arbitrary. It is not necessary to keep the same difference between 2 levels. But like this one, as you can see, the number 7 is higher than the number 3. And actually, the primary school has the lower education level than the middle school. So this code is not correct. And this is also the same in this 2 level. So it's not correct because the ordinal scale can be transformed according to the order of the ranking. Otherwise, it's not correct. And the next one is interval scale. And what is interval scale? Well, the temperature, the intelligence, the personality traits are the interval scale. And we can also interpret the ranking or the order in interval scale. We can see 5 degrees Celsius is colder than 20 degrees Celsius. Or we can say person A is intelligenter than person B. There is an item from the extroversion. I do not mind being the center of attention. And there is a 5-point scale with 1 strongly disagree and 5 strongly agree. And we can also transform them into like this. -2 represent strongly disagree, and 2 represents strongly agree. And the transformation is the linear transformation. So this is the formula of the linear transformation. If you are interested in, you can calculate the A and B in this case. In interval scale, there's also no absolute 0, so that we cannot form the differences or quotients. But the interval scale is allowed to form the quotients with the differences in the values of object pairs. What does it mean? For example, we can say the difference between 32 degrees Celsius and 16 degrees Celsius is twice as big as the difference between 15 degrees Celsius and 7 degrees Celsius. But we cannot say 32 degrees Celsius is twice as warm as 16 degrees Celsius. Or we can also not say the person A is twice as intelligent as person B. It doesn't make sense. And the next one is the racial scale. And what is ratio scale? For example, the length, the height, the weight are the ratio scale. And yeah, as you can see in the ratio scale, there are all of them information. We can interpret the ranking, and there is an absolute zero, and so that we can form the differences or the quotients. Where, for example, we can say, yeah, person A weighs 1.5 times as much as person B, or this tree is 3 times taller than that one. That makes sense, right? And the transformation is followed this formula. This is all about the scales of measurement in statistics in this video. Thanks for watching.